Hello, everyone. Good morning, good afternoon, and good evening. Dear authors and invited guests, welcome to the technical session 3C. Myself, Anshika Jain, and this session would be moderated by me. I, on the behalf of Global Knowledge Research Foundation and GIA Scholastic LLPP, as the international organization technical partner, Trinity University as a university partner, Venovate GMC as a local organization MIC partner, and Springer Nature as publication partner. It is my great pleasure to welcome you all to the 8th International Conference on Information and Communication Technology for Intelligent Systems, ICTIS 2024, Las Vegas, USA. The 8th edition of the conference is being organized in the hybrid mode. The physical event was organized in Las Vegas, USA on 23rd May 2024, and the virtual event is being held through Zoom today, that is 24th May 2024. I hope you will enjoy the knowledgeable sessions throughout the day. In this session, we are gonna have 6 presentations, and each presenter will be given 12 minutes for the presentation, 3 minutes for the questions and answers. On 10 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or any updates, then you can write it to me in the chat box below. Just before we get started, I would like to introduce you to our session chairs. Our first session chair is Dr. Ezekiel Uzor Okik. Sir is a senior lecturer in the Department of Computer Science, University of Botswana, Gaborone. Presently, he is the cluster chair of the Information Systems Cluster, Department of Computer Science, University of Botswana. His research interests are in software engineering, software measurement and models, information systems, security, cybersecurity, compilers, and high-performance computing. Welcome to the session, sir. Next, we have Dr. Narendra Londe, Associate
Thank you.
National Institute of Technology, Raipur, India. Sir is presently working as an associate professor in the Department of Electrical Engineering of National Institute of Technology, Raipur, Chhattisgarh, India. He has 12 years of rich expertise in academics and research. His main areas of research include medical signal and image processing, biomedical instrumentation, speech signal processing, biometrics, intelligence healthcare, brain-computers interface, artificial intelligence, and pattern recognition. Welcome to the session, sir.
Thank you, Anshika.
Okay. So, will you like to share a quick welcome remark with us?
I think without waste of time, we should just welcome one another to another interesting time, and we hope we are going to have it very interesting with all the presenters. And so I wish them happy presentations. Thank you.
Thank you so much, sir.
Okay.
Okay. So, shall I start with the presentation, sir?
Yes.
Okay. So, first up, we have Mariam, because due to her bad conditions in her country, she requested to put her presentation first. So, we'll be starting with Mariam Akhtar to present her paper titled Developing a Framework for Identifying the Scenario of Drug Addiction in Bangladesh. Are you there, ma'am?
Yes, ma'am. Would you help, please?
Okay.
Yeah, you may start with the presentation, ma'am.
Okay.
You can share the screen now. Your screen is visible, ma'am. You may start.
Hello, everyone. Good evening from Bangladesh. At first, I want to thank the organizer of ICTIS, and I also be proud and lucky to being a part of the 8th International Conference on Information and Communication Technology on intelligence systems. My paper ID is 161 and my paper title is Developing a Framework for Identifying the Scenario of Drug Addiction in Bangladesh. I am Mariam Akhtar. My co-authors are MD Tufail Ahmed, Sajjad Hussain Majumdar, Muntasir Karim Choudhury, MD Shahriar Zaman Abid, and Muhammad Abu Raihan. Outlines. This is the outlines of this paper. Introduction. Drug addiction refers to an addiction to a certain substance, which is the global consensus that is getting worse. The World Health Organization says that drug addiction is the chronic and intermittent intake of substance that is excessive amount that are not medically acceptable and becoming dependent on this substance. Our goal in this paper that we collected data and applying different types of pre-processing steps and also used machine learning algorithms and compare and analysis of result. Problem statement. We know that in worldwide, drug is hazardous for human life. We work with only a region of Bangladesh, basically Feni and Noakhali district. A person with a drug addiction and one without. There is a huge difference. Their social life, personal habits, family life, state of health. Thus, it is a therapeutic issue. It is necessary to work with drug addiction. Objectives. There are some objectives in this paper. Specifically, first of all, we collect data. We collect data from Kaggle, first of all, and we create different two data sets by using data from Noakhali and Feni district in Bangladesh. We also use different types of machine learning algorithm by using feature and also performance analysis, different types of metrics such as accuracy, precision, recall, F1 score, and ROC score. Furthermore, we also compare the result. This is the objectives of my paper. And this is the literature review of my paper. We also study a lot of papers and also included some of paper. This is the methodology section. Main section of my paper, data collection, which I also discussed in this section. Data basically collect in two ways. First of all, one data sets in Kaggle and another two data sets from Noakhali and Feni region. These data sets may be included slides, next slide. Data cleaning and data pre-processing. This problem is basically on regression types problem. So we also analysis, we also check that null value and delete or remove the null value. In pre-processing steps, we also use level encoding for converting character data to integer data. In train test state, we also use 80% data is training and 20% data is testing. In feature selection, there are many types of feature. There are many types of feature and only target feature is gender feature. Different types of machine learning model, training the model, and testing model only used as performance analysis and comparing the model. Dataset statistics that can be used. Dataset 1, it is number of data 2012 and columns 19, that is source is Kaggle. Dataset 2, 301 data, number of columns 17. That is self-collected data from Noakhali district. That is a 1092 data. The number of columns 17, self-collected data from Noakhali and Feni district in Bangladesh. Dataset 4 are combined data from dataset 1 and dataset 3. This is the section of feature is gender, education, life with, and motivation about drug. This is the section of dataset. Result and discussion. This is the result of dataset 1. All of the models in datasets provide the better results such as random forest classifier, K nearest neighbor, logistic regression, gradient boosting classifier, decision tree, SBM. And all of the models provide the better results, but the support vector machine provide the best results, which accuracy is 100%. Dataset 2. In dataset 2, All of the models provide better results, but the results is not best than dataset 1. The results accuracy is 59.42%. In dataset 3, that is the best results from dataset 1 and dataset 2 because of there are more and more data than dataset 1 and dataset 2. So the accuracy in dataset 3, 89.78%. That is the best results, and all other performance in these datasets provides gradient boosting provides the best results. In dataset 4, dataset 1, dataset 2, and dataset 3, from all of these datasets, dataset 4 provides the best results, and SVM classifier provides the best results. Accuracy is 94.45%. All of this analysis in conclusion section, in abstract section, we see that we analysis that the best accuracy is 94.45%, and we measure that the all other parameters provide the best results in this algorithm. Conclusion and future work. It is strongly advised to put various interventions into practice that target the risky behaviors associated with teenage changeable lifestyles. In detail in this section, in this article, among all of these algorithms, SVM comes up with highest accuracy, 94.45%. In future work, we only work with drug addiction area-wise, not only Feni district or Noakhali district. We only work whole Bangladesh, suppose such as Dhaka, Kumilla, that is the risky in the drug addiction. So we also collect data from the authorized center, varied data sets, and also more algorithms. And in this paper, we only target feature is gender, but we also work another features and performance calculated for suitable architecture. We also conclude references, different types of reference in this paper. And thank you all.
Thank you so much, ma'am. Sir, do you have any questions?
Yeah. Which tool? Can you hear me? Which tool
Yes,
gave you the ML algorithms you are using? Which tool are you using to generate this?
basically, sir, as VM classifier, logistic regression, gradient boosting classifier.
Yeah, I know those are the ML algorithms you have decided to use, but they come in a tool. Which tool is that?
Basically, as VM
you can't
classifier
just be selecting. You can't just select them here and there. For example, there is a WICA, the Waikato Environment for Knowledge, is it knowledge extraction and so, which also is a tool that combines all these ones. So which tool are you using?
Basically, SVM and logistic regression.
Those are the algorithms, but they come as a tool on the, for example, if you check WICA, you will find the WICA tool is the Waikato Environment for Knowledge, is it knowledge advancement or extraction? WICA, W-E-K-A, you will find these tools also. They are used for knowledge extra. You want to use them, and they have this ML classifier. They have also the preprocessors and so on and so forth. So yours must have come as a tool in I don't know where you are getting your tool from.
So I have basically
you go back and check.
I have basically sir work on simple machine learning algorithms, area-wise classifications, gender-wise, different types of feature. WICA that not work. I am environment, Kaggle, and Google Colab, and basically comparisonal work in this paper.
Looks like someone wants to say, chip in something.
Yes, sir.
Hi, Sharon, you want to say something?
Hello, sir.
I cannot understand.
Yeah, can everybody hear me?
Yeah.
So yeah, I think the Google Colabs and Google Colabs is an environment where you can code, right? But to decide on which algorithm to use, I think that's the question that Dr. Okiki is are trying to ask.
Yes, I am going to the question, but I wanted to know the tool where she is getting her algorithms from,
Yes.
because I was going to ask her what informs her choice of those algorithms, because you must know why you are using specific algorithms for specific things. So if she's using the Waikato environment for knowledge extraction or advancement, which you use, it has all these tools. It explains situations where you can use each of those algorithms. Before you justify that SVM, what is your SVM?
Basically, sir, target is classifier. Basically, target is
It's a classifier.
gender.
What does it mean?
Mainly target is gender, male or female. So this is classifier. SVM is also a classifier algorithm. So this can be used in this problem.
Yeah, it's an acronym. You must tell us what SVM is. It has to do with, think, virtual machines, statistical virtual machine. You must know what you are using. So I know it's a classifier, but
Yes.
you must know what the tool you are using. You don't just use any tool before you say this is the best classifier. So you need to check what is SVM. I'm just educated. We are just learning together. So as you present, you must know what you are using so that you can justify your results.
I basically use different types of algorithms, and SVM basically works with hyperlines, maximum majority values and minority values. And then we use the gender values as male and female. There are two values, 0 and 1. And that classify these values, and we use different types of performance metrics. And SVM results is the best. That's why it is the best results and is the best algorithms.
Okay, so I give you an assignment. When you finish, check what is SVM. You must know what SVM is. All right. I don't know, because there are classifiers. There are ones you can use for pre-processing. We know that, and so on and so forth. You must know specific things of what you are using and why you think that this tool is the best for this. I'm sorry for taking your time, but it's a good study. Has there been any study like this in Bangladesh?
Yes, sir.
Okay, there has been. Did you compare your results with that study? No. You may also have to check. Yeah. When you do research, are you an MSc, PhD, or an instructor?
MSc, sir. MSc, sir.
MSc, okay. So when you do research and you do your literature survey, you also have to check what others have done. How did they do it? Which tools are they using? You must understand what those tools are, and then you check your results. If there is consistency in the results, then you'll be able to speak to the results you are getting. If there are differences, you can also find out, why is my result different from this one? Okay. I don't know if any other person has anything to say.
Yes, sir.
Okay, so make sure you update this in your final submissions to them. Okay, so that you check if there are studies done like this, look at your results, you make a comment about that in your summary. Okay, and tell us the tool set you are using. We know you have used this machine learning algorithms. Find out where they are coming from, because I'm sure you don't just pick them here and there. There must be a tool set that gives you this one. Like I have mentioned, Weka. You can even check if it is from Weka you are getting them from, but you didn't know. If you find all of them in Weka, then look into each of those algorithms, okay, and see what they said about when you can use this or this or this or that. Okay, thank you. Is there any other question?
Thank you, sir, for your suggestions, sir. Thank you, sir.
Okay, all right.
Thank you, sir.
Okay.
Thank you so much, ma'am. So there are any questions left?
Yes, Anshika, please go to the next one now. Enough
Okay.
suggestions are there. Thank you.
Okay. So we're moving on to the next presentation. Next up, we have Angelique to present her paper titled Analysis of Energy Harvesting for Self-Powered IoT Edge Node Devices Applied. Are you there, ma'am? In a biogas generation context. Are you there, ma'am?
Yes, yes.
Okay. You may start with the
Can you hear me?
presentation, ma'am.
Okay. Oh, thank you very much. I'm Angelique Mukasine. I'm a PhD student at the University of Rwanda, and I'm happy to share with you one of the research outcome that I have been conducted during my PhD research studies. So the title is on analysis of energy harvesting for the IoT device. The presentation will cover the following content: introduction, related works, methodology, result, and conclusion. So as I said, this is a part of my research work, whereby in the previous research, I made an IoT kit to monitor or to control the biogas production by considering only environmental parameters. So after developing the system, I found out that the power, normally because the digester used to be deployed in the electricity constrained environment, the system or the wireless sensor node we developed is recharged by a power battery. And as you know, the power battery needs to be recharged more and more often. So to maximize the IoT system utilization, there is a need to apply appropriate energy harvesting technology. So the contribution of this paper is to analyze appropriate power harvesting approach to sustain our designed sensor node. So in order to do the research, you have come up with some literature review in the field. We have come up with so many papers, but I have tried to summarize only the three. But all of them, they have tried to focus on proposing power harvesting for the general IoT devices. But as you know, since the embedded system used to behave differently, there is a need to investigate a power harvesting for a specific system. That's where comes our contribution to analyze the power required for the designed sensor node, not for all, or specifically for the sensor node we developed. So in the methodology, on the right side, you can see that after investigating so many renewable resources that can be applied, we have found out that the solar harvesting is the most appropriate for our case study, since the biogas is generated outside on the sunlight. So this is the most appropriate for that case. So we have our sensor node here with all the sensors and the processing unity. So in order to analyze appropriate power harvesting, of course, in the next point, we have analyzed our sensor node energy consumption, whereby each and every device attached has been analyzed in 3 modes: sleeping mode, active mode, and the transition mode. And in the end, we have made a summation of all the power consumed in all the 3 modes using the formula we have here. On the second point, of course, we have tried to analyze, after getting the energy consumption of our device, we have tried to find out the power specification of each and every power harvesting subsystem, whereby the power battery size, charger controller, and solar panel have been investigated. And those are the outputs on the specification of our power harvesting system. As a main contribution of this paper was to develop a solar panel size prediction model, whereby it's like we are thinking that our sensor node can be deployed anywhere as long as we have digester there. They can be deployed in so many environments. That's why you have tried to map out this prediction model. So the prediction model is based on a mathematical theorem, say about the behavior of derivative that converging at a specific point. So refer to this theorem and having the sensor node energy consumption. Also, one of the input is the global horizontal irradiation available in the deployment environment. So we have tried to use the sample data we have in order to do all to explore and see our output. As you can see on the, we have used this simultaneous equation. We have tried to explore this simultaneous equation in order to get the result. So those are different mathematical modeling we made. We replaced with the sample data we have tried to replace in the equation until we get our final equation, which is the model we were expecting. Actually, the model is this, meaning that at any place you can calculate the power, the solar panel size given the global horizontal irradiation in that environment. And as a result here, you can see we are having a correlation between global horizontal irradiation, the solar panels, the expected solar panel size, and of course the expected solar energy production, referring to the model we have. And as result conclusion, the result shows us that the sensor node can be powered by a panel size of 3 centimeters, given an optimum of 5.5 global horizontal irradiation available in the deployment environment. Also, we provided the data reveal a systematic reduction in solar panel size with increasing of a level of global horizontal irradiation. Also, it demonstrates an interesting relationship between solar exposure and solar panel dimension. Also, it shows us a correlation hint at the point of the potential of leveraging high radiation to achieve effective energy capture within a small physical print. So as a conclusion, this research proposed a power harvesting to guarantee the lifetime of our sensor node and smoothly operation of our sensor nodes. Also, it analyzed energy harvesting subsystem. Also, a mathematical model to predict has been given for a given global irradiation. The model was validated for different values, and it is generic to be adapted anywhere. This is the end of my presentation. If you have questions, please.
Thank you so much. Sir, do you have any questions?
Let Professor Narendra, if you have a question, then I can chip in something.
Hello. Yes. Basically, presenter, I just have one suggestion to you as you're talking about energy harvesting. Okay. energy harvesting will be coming from the, the 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 source that you have shown is only the solar. There can be some other sources also. Along with that, whenever you store that energy, okay, capacitor, batteries, as you have said that in the conclusion that you have explored those things, you should have shown that curves of the devices as they are charging and discharging. Then only it would
Yeah.
have been a proper concept that yes, solar harvesting has happened. Okay, so these are the along with that, there is one very important question that comes in the solar harvesting, that when the solar is not available, okay, so it is, if it is a night time, then in that case, how the power will be provided to your network? So that is
Yeah.
also one question that you should have addressed. Okay, so that is just a suggestion from my side. Maybe you can improvise on your work with those suggestions. So thank you once again.
Yeah, that's very good. I was also going to ask questions on how it was validated, because I think, though she summarized, generalized that it was
Generalized.
validated with various, yeah, it's too
Right.
generic to say that. You have to be
Too
specific
generic.
on how the validation. Yeah, yeah. Those are just my comments too.
Thank you so much, sir.
Okay.
So we'll move on to the next presentation. Next up, we have Jalkar to present his paper titled Cloud-Based Multi-Class Traffic Object Detection Towards Autonomous Vehicles. Are you there, sir?
Yes, Ms. Jain, thank you for the introduction. I'm going to be sharing.
Yes, sir.
It seems like I don't have the permission to share the screen yet.
So you have the permission. You may start now.
Okay, I got it. Please let me know if you can see my slides.
Yes,
And
we
if
can
I'm
see the
audible.
slides. You may start.
All right, so hello everyone. Welcome to my presentation. My name is Julker Nain. I'm from TU Chemnitz, Germany, and my co-authors are Mubashir Ahmed and Professor Dr. Wolfram Hart, both from TU Chemnitz. The topic of the research is cloud-based multi-class traffic object detection towards autonomous vehicle. Here are the outlines. So I'll first briefly talk about the motivation behind selection of the research topic. I'll talk about the autonomous driving pipeline, the generic conceptual model, the methodology and implementation methods that we have used. We'll go over the results and evaluation, and finally talk about the conclusions and achievement. Over here, we can see on the right-hand side a commercially available mini vehicle, miniature vehicle, and we used this miniature vehicle and added our enhancements on it to do our research work. We'll talk briefly on this as well. So the automotive industry is slowly but surely moving towards autonomous driving systems. But testing any sort of autonomous driving systems is in real world scenario very expensive and as well as unsafe. What if the algorithm or the technology just invented does not go accordingly? So a solution of this can be an autonomous mobile vehicles, which are normally used in industrial mobility for heavy lifting. But these mobile vehicles have a low battery capacity and lack the onboard computation quality capability as well as they have a high latency on board chips. A solution towards these kind of problems is deep neural networks, but these deep neural networks require immense computational resources. And on top of it, the hardware that is used, these GPUs are bulky and power hungry, which cannot be mounted on top of these miniature vehicles. So our solution is to have a client-server architecture so that we can have a miniature vehicle work as a client, and we can have a server, a powerful GPU-based server, and offload all our computation onto the server. we found out that we needed to have a latency below 100 milliseconds in order to achieve real-time accuracy so that the car can react according to the scenario. And this we had targeted for. And this would include reducing the onboard inference dependencies on the edge computation devices. And obviously the target is to improve the road safety by detecting different traffic objects and signs and automated steering. This altogether comes towards the same topic of situation awareness, being aware of your surroundings on any given certain scenarios and actuating therefore. So our prime research challenge was to develop a real-time autonomous driving system using a client-server architecture. And we distributed the work in 3 different segments. The first segment was edge server computation. So we needed to have edge server computation, edge server client communication with almost as low as possible latency.
Hello?
Along with this, we needed to have robust road sign detection models because road sign detection is a traditional technique that is
Yes, come
used.
to you beyond that.
But in harsh weather conditions, it is difficult to detect these objects, and we aimed to detect these objects during harsh weather conditions, either snow and rain and other foggy conditions. And finally, it is okay to detect an object, but it is a different factor to have an actuation done on different road surfaces and road curvatures and different types of scenarios. So we also developed an algorithm to have an automated steering for this miniature vehicle as well. The state-of-the-art autonomous driving pipeline looks somewhat like this. So we have several sensors, and these sensors are providing extracted data from the environment to the onboard perception model, where one can either detect the signs, lanes, and other objects. You can also do a localization as well, and after that you have 3 options to route plan, behavior plan, trajectory planning, and finally do the actuation. For us, we wanted to made a prototype, so we focused only a single sensor, which is a camera sensor, and we did our computation on a cloud server based. And based on it, we had the behavior planning, how the vehicle should behave and steer, and provided the information to the actuator. So this is our generic conceptual model. As you can see, we have one end. This is the server, edge server, and the autonomous mobile vehicle acts as a client. Initialization of the server is the first step, and also initialization of the client hardware. We then control the thread and transmit the thread, and this thread, this frame that we are sending are encoded in such a way that the data has a level of security. You always have to make sure that the connection is always managed between the client and server. Once the encoded data is received, this data is decoded. Then we have the sign detection model and steering angle prediction model. Once we have the results from both of these models, we have a final result which is sent to the client, which is always listening, and then we decode it again. And finally, we have the action request of how to behave on certain scenarios. And finally, the car behaves. So we used an onboard Raspberry Pi 4B device, edge device. We also replaced it with Jetson Nano devices. We played around with Raspberry Pi and Jetson Nano as our onboard client. But we used a Raspberry Pi version 2 CSI sensor camera, which was able to stream 30 FPS. And we converted the raw frames into JPEG format, which is accepted by the model itself. The frame size was 640 by 480 pixels. The compression quality was 70% due to the low latency we wanted to achieve. And this is how the bidirectional edge server communication looks like. The camera, we gather the frame, which is raw data. We do some processing on converting the raw to JPEG, and then we have the bidirectional communication between the server and the client. And this data is received and finally inferred to the model and sent back to the actuator. So in the case of bidirectional edge server communication, the traditional method is to use single thread communication where we provide a frame, and this frame has transmission time, and then along with we have some processing time, and then we have the response time on top of it as well. But the problem with single thread communication is that in between threads, frames, there is always a waiting time. We try to remove it by having a multi-thread approach. So we send multiple frames at a time, and which has the processing time and response time, transmission time, processing time, and the response time, and giving us this opportunity to remove this waiting time altogether. So that was about the edge communication. And the second point is about the object detection. And for this, we decided to use YOLO version 4, you only look once, because it's a very fast algorithm that we can go for. And our prime target was to go for data acquisition. We splitted the data into 75, 15, and 10 with regards of training, validation, and testing. Converted into YOLO format, did some augmentation because we started with a very low amount of data. And once the model is configured, the training is done, we check with the map score. And if the map score is high, that means the accuracy is high, we forward the model and we use the model for the inference. If the map score or the performance is accuracy is not high, we retrain the model and redo it once again. For data acquisition, we used 877 images of 4 different classes only as a prototype, and we converted the encoding to JPEG format. As already mentioned, splitted the data set into 75, 15, and 10 for training, validation, and testing, and resizing it 416 by 416. And for augmentation, we took the original image and then we rotated it to 15 plus minus 15 degrees. We blurred it. Then we increase and decrease the noise and brightness by plus minus 25% as well. And then with the help of YOLO v4, we added mosaic techniques. So mosaicing provides different backgrounds to the object that you're looking for. And that gives us the opportunity to detect the objects, even if half of the object is obscured in different harsh conditions. So once the edge server communication is done and the algorithm is able to detect the object, the information is provided to the steering controller because the car has to drive properly in that manner. And here we used a steering prediction model, which is based on imitation learning model. Now, what is imitation learning model? Imitation learning model is to learn by looking at some data that you have. And here we added a wireless steering controller to the vehicle itself and drove around hundreds of iterations and gathered those human-driven data. Along with this, we also captured the lane images of the vehicle that was driving, and we created a data set out of it. And then we trained the data set with a convolutional neural network and used the same data set to infer and finally decide the steering and angle control. Here's another overview. So this is an original frame from the camera that is mounted onto the car. We go for a region of interest because the background is.
Sorry to interrupt you, sir, but you have 2 minutes to conclude your presentation.
Okay, so then we do some pre-processing, and finally, after the convolution neural network, we have the prediction steering value. So this is the computing platform. We used the Google Cloud Network to train our data. We used RTX 3060 for the inference as the cloud server, and we used Jetson Nano and Raspberry Pi for this for the client edge devices. As we can see, we have tested with more than 100,000 packets to be sent, and the latency that we found was 36 milliseconds with 2.4 gigahertz. That meant it was way below 100 milliseconds that we're targeting for. And on the evaluation of the tested models, we went for different sets of augmentation, and we decided to go for augmentation method 2, we call it, with a map score of 86.58%, which gave us a trade-off of using lesser amount of data to train the model and getting an accuracy good enough to detect the objects. Finally, for the evaluation of the steering prediction model, so we overlaid our prediction angle model results on top of the human control level, and we found out that 90% of the cases the steering prediction model was accurate. And then out of the different devices that we tested our model on, we found out that our FPS pipeline was 29 frames per second on the target hardware. We also tested on Jetson Nano as a server. We got 17 frames out of it. We also tested on Raspberry Pi devices, and to showcase that the onboard devices are not good enough to compute at this level with a 0.820 FPS. As well as the reaction time of onboard computing. If we do it on Raspberry Pi, it becomes 1249 milliseconds. On top of it, on the edge server, it's 44 milliseconds for the whole round trip from the frame being sent to the detection model being done from the to the car reacting. So which is a pretty good real-time effort. And by removing the computation from the onboard client board to the edge server, we were able to reduce the power consumption on the Raspberry Pi to 40% and Jetson Nano to 50% of lower power consumption required. So at the end of the day, for the research, we have developed robust multi-class sign detection model with 87 MEP, scalable steering prediction pipeline, offloading computation pipeline for autonomous vehicles with 30 frames per second, actuated the vehicle in autonomous mode, reduced the battery consumption and the onboard processing for a green future. The future aspects is that we can use a better camera with a wider lens, and also we can have a backup safety module algorithm set up on the car itself, for example, collision avoidance only and safety mode, which at this point of time is already being executed. And we can also make use of the current technologies like 5G technologies in the future. Yeah, so these are the references. Thank you for listening, and I'm open to your questions. Thank you.
Thank you so much, sir. Sir, do you have any questions?
We cannot hear you, sir. Sorry.
Professor Okiki, you're mute. Yeah.
Okay.
Yeah.
Yes, I was going to ask him his plans for the future, but good enough, he covered it at the end of the study.
Okay.
I was going to ask how it's going to work with the 5G. Does he have that kind of plan? But
so
good enough, he mentioned.
Maybe I can take 10 seconds. So with the current work that we have, it is focused on a single vehicle. With 5G technologies or better wireless banding, what can happen is that we can add multiple vehicles in a certain scenario and have a car-to-X and car-to-car communication, which is not yet done. But the good news is that we're currently working on it, and hopefully in the coming months that will be done as well in our labs.
Professor, do you have any question for him?
Yes,
Yeah.
yes.
Please.
Mr. Julkar, I have only one thing that I want to mention about your experiment.
Please.
You see, whenever the vehicle moves, okay, on any road, actually, its speed changes.
Yes.
So when the camera captures the images
Yes.
of, say, signboards or maybe whatever the obstacles coming to the vehicle, okay, that because of that speed, that images may get some motion artifacts. Okay.
Yes.
So it is really necessary in such kind of experiments that you should perform these experiments with different speeds and see how your algorithms is working with one speed, with another speed, and
Yes.
higher speeds.
Yes,
Okay.
we have done that with different variations of speeds. So for this particular example, the car that we used had 3 different variations of speed. For example, it is low, medium, and high. Yeah, we could not get the actual speed because of the lack of the speed sensor. But with this speed, we drove around different conditions, and we found out that the algorithm that we use, because of the augmented mosaicing that we use for the training of the data, even if the traffic sign is blurred or the traffic object is half of the object is obscured by any other vehicle, for example, there's a stop sign, but there's a vehicle behind the stop sign, almost hiding half of the sign. This algorithm was capable enough to detect it as well. And we are doing much more experiments with our with our department built demonstrators due to Due to issues, we cannot show it over here. NDA issues, we cannot show it over here. So that's why we're using a commercially available vehicle. But
Yes,
hopefully
yes.
in the
One,
future,
one more
general
thing.
version.
How was
Yes.
the response time in the case of the speed was very high?
Yeah.
Because the data is going to the server, then the cloud is having the programs, then it is running, then it is generating the results, it is coming then back to the vehicle, and
Yeah.
then vehicle is responding. So
So
how was
we
the
did.
response time in the
Yes.
high speeds?
Thank you, sir. So we tested with 3 different speeds as well. And for each of the speed sections, we sent an average of 20,000 frames as packets. And we found out that the total latency altogether was 34 to 36 milliseconds. So it's another story that the accuracy is only 86%. It can get better, but we wanted to have a fast result. Hence, we used that also has to be taken into consideration that we only used 877 images. On the other hand, with the data set with on top of which is yellow is built is based on 328,000 data. So we targeted with lower amount of data, faster trained algorithm with low latency, which was 36 milliseconds, and yeah, so that is the result that we found out for all of these different speeds that we tested.
All the best. It's really nice work. Keep doing your good work. Thank you so much.
Thank you so much, sir.
Okay.
Thank you so much, sir. So with this, we may move to the next presentation, please. So next up, we have Celestilia to present her paper titled Digital Shadow Methodology, a real-time measurement techniques for thermal comfort. Are you there, ma'am?
I am not Cecilia Bolognesi, but I am the co-author of the paper on behalf of Professor Cecilia Bolognesi. I've got the presentation for this paper.
Okay, sir. So you will be presenting on her behalf?
Yes, I'm presenting on behalf of Professor Bolognesi. I've got the presentation, and if I can have the screen, I can present on behalf of Professor Bolognesi.
Yeah, sure, sir. You can present on her behalf.
Yeah.
You may please start the presentation, sir.
I can start presentation? Okay, thanks.
Yeah.
Okay, I hope you can see my screen.
Yes, sir. We can see your screen.
Great. Lovely. Okay, so I am Domenico Duva. I am the co-author of this paper with Professor Cecilia Bolognesi, who excuses because she has an urgent matter, so she gave me the possibility to present on her behalf our research. The research is inherent digital methodology for measuring thermal comfort through a system that we're going to explain. So the aim of this research is to visualize comfort index based on real-time environmental measure. The measure will happen in real time and the results will be in real time. The step-by-step procedure which arrives to this matter is taken through the survey of the building. We are in the field of architecture, better to specify that. We have worked on a building from our university, and we are trying to do this process to survey the building, model the building starting from a survey, coding the system that drives all this procedure, and then visualize the thermal comfort index. The survey is based for this building, which is in Milan, where our university is located in Italy. And this building has undergone a survey done in 2 steps with a handheld laser scanner with the combination LiDAR cameras and IMU. There have been 2 scanning campaigns. First of 20 minutes, which is on the building only, which is around 100 million points. And the second about the context, which is the lower left images, which is a context which is taking 30 minutes and 15 million points. Once the survey has been completed, there was the modeling phase. The geometry survey in a building, which is the survey phase, is like investigating musculoskeletal system for human being. We made a parallel between the building and the human being to make it clearer. So the modeling phase is based on the point cloud. The point cloud is the million of points which are surveyed with machine, and our work of modeling was to fit in the cloud some polygon which makes up the building divided by single component, divided and made up in an informed model. So each of the component has relationship with the nearby component, so that they can react in a realistic way. And this is called the building information modeling system, which is very spread in architectural world to define and build digital model. This model has a very thin precision, which is the distance between the model and the real building, which is surveyed, is less than 2.5 centimeters. So it's very, very precise in terms of architectural scale. Once the model has been completed, there was the analysis of the flows of energy. The fluxes, like the blood and the organic fluid, works in a human being. This fluxes is built by the code. Before starting with the code, it seems important for us to describe the difference between digital shadow and digital twin, because most of the groups in architecture speaks about digital twin, where the relationship between the real building and the digital building is completely automated. We are just one step before, with the difference between the path from real building to digital building is automated. The rest of the inverse procedure it is manual, but we are plan to get it completely digital in near future. The system is based on a real low-cost sensor and open source, which is a proudly Italian system called Arduino, which is very important because this system is completely free of copyright, so you can reproduce all this system, because all the data can be from this kind of hardware can be freely rebuilt, and it is freely available for the use and reproduction. The system has a monitor for four variable for temperatures, humidity, pressure, and illuminance, but for the purpose of analyzing thermal comfort, we just consider temperature and humidity. We passed through different workflow which tries to reach the result. The first is the most common way to solve this problem, which is working with the Wi-Fi system, which speaks with the external world with the sensor, and going through a procedure by one of the most important modeling system, which is Rhinoceros, and its subsystem, which is called Grasshopper, and in plugin, which is Firefly. This system arrives into the model, which you have seen before, but the problem is that this is just like a Matryoshka, because you have the Revit system, and inside this Revit system, there is a Rhinoceros system and then a Grasshopper system. So this system has a huge problem of compatibility and of interaction between different applications. Then we passed through a more linear system, talking only about Python. The problem with this system, which seemed easier, was to the staticity of the system, because this system produced a JSON file, and this JSON file was inserted into the Revit model. The problem is that these were static file, so TXT file or CSV file, which should be processed and taken out the result like pressure and humidity. The third and actual workflow used was the Arduino system, which spoke with the cloud and derived the data into Dynamo. This system was very complex to work through because it is the Python system which works inside Dynamo, but it was much faster, much easier to make all these pieces together. There was a simple operation of coding into an environment, and once the system has been connected, it produces a file which is in real time. It means that once I have to define the comfort system, the system the modification of the wall color. It means that we defined a wall in this building, which is exchanging its color in real time in comparison, so in relation with the thermal comfort. It is easier to see it than to make it work. We defined, as for the European rule for the comfort range, for temperature, which is on the left column here, and humidity for the for the right column. This building has put as a sensor in this position, and when the system is working, currently it is working, we design with all this workflow to make the color of this wall lighter if it is this environment it's outside of the comfort range, or green, more vivid green if he's inside the comfort range. We are speaking about humidity because if this system, if these sensors measure and humidity in this comfort range, you have a real-time modification of the digital model. So you have complete control of what happens just by having a look at the model. The same happens with the temperature. If the temperature is outside of the comfort range, it means outside of 18, 22 Celsius in winter and 40, 24, 26 Celsius in summer. When it is outside of the comfort range, means the temperature is lower or higher than the comfort range. The system is colored into different variation of colors. The accomplished step during this year of research was scanning the system, building the model, theorize the digital strategy because it was very complex to think of a digital strategy, and put in place a single station, connect the sensor outside of the case study because the problem with the faculty was that it was very complex to make it work inside of the university. So it was just a first step which was worked out outside, then brought inside the case study. Then the later operation was to
Sorry to
perform
interrupt
digital
you, sir.
shadow.
Sorry
Is
to
the
interrupt, sorry to
yes,
interrupt you, sir, but you have 2 minutes to conclude your presentation.
yes, I've got 2 slides more. It's I'm finished, and the data transmission through digital shadow is currently transmitting in real time, and there is an additional sensation in operation. What we want to achieve is a full-scale experimentation with free station, a year-long data collection, an addition with CO2 sensor for measuring the occupancy and the issue with the system, the connection with the environmental agency, and digital twin completion to complete the system. And if you care for further updates, you can write us, and thank you for your attention and patience. Thanks.
Thank you so much, sir, for your presentation. Sir, do you have any questions?
I was going to ask about how about environmental changes in seasons? How does it factor into this work? I had him mentioned some.
Yes, the environmental changes are very, very important because we would
When
like
the weather
to.
is stormy, go ahead.
No, sorry, I was
Go on.
interrupting you. You were saying, no, I mean,
Yeah, go ahead. Environmental changes. Okay.
Okay, yes, environmental changes are very important, especially because this is located in Milan, and there is a huge problem with the pollution in the city because the plain in Milan is very, very polluted. So there is a very complex way of working out that the renovation of CO2 should be worked out only when the environmental data says, okay, you can open the window, but sometimes it is much better if the windows stay closed because you can make the pollution from outside getting inside. So it is a system that should be spreaded into a large system, to a large lot of houses because it can improve the quality of life inside this building just because of the connection between internal data with CO2 and thermal comfort and external data, which is the data for environmental, so pollution, so small particle PM2.5 and PM. So it is a very important part of this. Just to be short, this is a small piece of a huge project of research which involves 4 universities and more than 150 researchers and teachers which analyze the environmental problem with a wide variety from psychology to architecture, structure, thermal line. So it's a very, very big project, and this is just a very small piece. So environmental change is the base of the work we are taking through.
And I hope you do realize that WHO, they have their standards for this environmental pollution in terms of the gases,
yes,
for the sake of improving human life. So
yes,
whatever
exactly.
you are doing, you have to measure what you are doing with the WHO standards. I was just holding a paper that has to do with medical geography, a study that has taken some households, and they are trying to measure some kind of
Yes,
things.
it's
The very
specifically
similar
designed.
things.
This is
Yeah.
specifically designed for household. This is a former library, but this project is just a case study that should be replicated in a larger system of case studies, and this can define a standard for certain type of houses which has some environmental performance, because all this system is based on trying to do just possible solutions, not a very, very, very expensive solution, just cheap solution with low cost that can be applied in very large areas so that you can make the difference. I mean, it's important.
Yes. Okay.
Okay, thanks for your
Professor,
question.
do you have any question? Yeah.
No, I don't have any questions. It's really truly said that, sir, that with time the things will evolve about this project. Then only the real problems will come out, and then they will be able to address those in sequence, and that's how their system will improvise. So
Okay.
best of luck, sir. Thank you so much.
Thanks you so
Thank
much.
you.
Thank you.
Okay.
Thank you so
Bye.
much, sir. So we'll be moving on to the next presentation. Next up, we have Franklin to present his paper titled Effect of E-Leadership on the Decision Making of the Managers of the Flower Sector of the Sabana de Bogota. Are you there, sir? Are you there?
Hello.
Yes, sir, we can hear you.
One moment.
You may start with the presentation, sir. Your screen is visible, sir. You may start.
Okay. My name is Franklin Buitrago, a PhD student in management, University in Bogota, Colombia. working doctorate thesis, effects in leadership on the decision making of manager on the flower sector of the Sabana, Bogotá. I don't speak English.
Yeah, I'm gonna assist Frank in translating to English.
Okay. Objetivos.
Yeah, the objectives of the thesis, the main goal is to determine the effect of the leadership in the decision-making process of managers in the flower sector of the Sabana de Bogotá. The question for the research is, how does leadership affect the decision-making process of managers in the flower sector in Sabana de Bogotá? And the hypothesis is the leadership has a direct impact in the decision-making process of managers in the flower sector.
Okay. The flower sector, tenemos alrededor de 400 compañías.
There is around 400 companies in the Sabana de Bogotá.
Somos el segundo productor a nivel mundial de flores de exportación.
We are the second country with most flowers exported in the world.
Con alrededor de unas 8.000 hectáreas sembradas en flores.
Hectáreas, no sé.
Acres.
There is around 8,000 acres. Flower crops acres in the Sabana de Bogotá.
Y unos 150.000 empleos directos general al sector.
Yeah, that generate 150,000 direct jobs.
Ok, nuestro pregunta de investigación, evalúa dos variables.
The idea of the thesis is evaluate two variables.
Y leadership and decision making.
One is leadership and the other one is how to make decisions.
Es una investigación correlacional explicativa.
Is a correlational research that the idea is to explain the relationship.
A través, pretendemos medir las competencias digitales y su incidencia en la toma de decisiones. Medir las competencias digitales en la toma de decisiones.
Yeah, so the idea is to measure the digital skills and how they impact the decision making of these companies.
Una investigación cuantitativa.
Yeah, it's a quantitative research.
Ok. Vamos a utilizar dos instrumentos.
We're going to use two instruments.
Sorry to interrupt. So, are two people presenting from your side?
Sorry?
Sir, two people presenting from your side?
No, there is interpreting for him.
Okay, okay.
Can we continue?
Yeah, you can continue, sir.
Okay, cool.
Ok, los dos instrumentos.
So there is two instruments for this thesis. One is 6E competency instrument from 2017, and the other one is general decision-making style instrument that is from 1995.
Ok, estos instrumentos, la idea es con estos instrumentos mirar la correlación que hay del liderazgo electrónico con las competencias digitales. Vamos a iniciar el proceso de recolección.
The idea is to correlate these two instruments and see what are the impacts from the skills in the 6E competency instrument with the general decision making.
Entonces vamos a iniciar el trabajo de campo de recolección de la información y esperamos obtener resultados el próximo año.
Right now, we are contacting the CEOs and the companies. I used to start making the surveys and start gathering the information and cross-reference that to find results.
Una muestra de 200 personas.
The idea is to make a survey for 200 persons at the beginning.
Okay. Question.
Yeah, any questions?
Thank you so much, sir. Sir, do you have any questions?
Myself. The presentation is so brief. I wanted to understand really this concept of e-leadership from his point of view.
Quiere saber qué
So what is it?
significa
What is the study going to achieve?
Liderazgo electrónico. Ok. El e-leadership o liderazgo electrónico es el poder de convencimiento a través de las herramientas digitales.
The idea of leadership for Franklin is how to ¿me repite?
El poder de convencimiento, de persuasión.
How you persuade the people through the virtual environments or virtual communication systems.
Para obtener los resultados organizacionales.
Yeah, to transfer the goals of the company and actually steer that to make, like, to accomplish some goal by the C-level.
Yes. How does it relate to the concept of multi-criteria decision making? Multi-criteria decision making. Does it have any relationship?
Yeah, can you repeat the question, please?
Is there any relationship between what you are doing and the concept of multi-criteria decision making in an organization?
Que si hay alguna relación entre lo que está haciendo y el múltiple de toma de decisiones en las empresas.
Que si hay relación entre esos dos instrumentos. No, en este momento no he visto una relación entre esos dos instrumentos y precisamente eso es lo que queremos averiguar. ¿Qué relación hay?
Yeah, so far there is no relationships between the, but the idea of this project is to gather the data and see if there is some relationship between those two.
Okay, Professor, do you have any things to chip in?
No, I think that they just have presented the concept. Okay, that e-leadership is something related to the flower production, how the flower production can be maximized. Okay, how they should manage their manpower and the resources so that they can increase the flower production. So it's nice thing, and I'm really happy that it has been taken for this topic has been taken for the doctoral thesis. And congratulations, Franklin sir, and thank you so much.
Thank you.
Thank you so much, sir. So with this, now we should move on to our next presentation. Next up, we have Sharoon Sharif to present his paper titled Optimization and Implementation of a 32-bit MIPS based softcore processor to run statistical algorithms on FPGA. Are you there, sir?
Yes, I'm here. Thank you so much. I'm trying to pull up my paper right now.
You may start with your presentation, sir.
Is my presentation visible to
Yes,
everybody?
sir. It is visible. You may start.
Thank you so much. Greetings to everybody. My name is Sharoon Sharif, and I'm a master's student in Alabama A&M University. And the people in the research were involved: my peer Meek Simbale, Tiger Kabil, and faculty members Dr. Sita Kandamadugula, Dr. Zhang Xiao, and Dr. Andrew Scott. So this is the outline that I'm going to follow through my presentation. And for the introduction, this is the flow that we have used for our research project. We have first designed a MIPS-based single cell processor, and then we optimized it by introducing instruction set architecture. And then we have implemented 4-stage pipelining into that optimized single cell processor. Then we tested mean calculation as a test algorithm, and then we implemented it on FPGA and analyzed the performance. So this is the architecture for MIPS-based single cycle processor. This was all written in Verilog HDL, and we have tried to build a very simple processor at first so that we could test the hypothesis of SOMA instruction set architecture. So you can see the flow of the control unit and the program memory. The first optimization that we introduced into this processor was the instruction set architecture that was proposed by Dr. Perry Youngworth and Dr. Andrew Scott 2 years before. And this has two categories, two theoretical proposals. One was to clubbing the register and integer logic into a register integer class. And the second one was to introduce the branching similar to C-like branching in the machine code processing. So as you can see, the custom instruction set architecture that on the left hand side, the bit number 26, that is the mode selection bit. If it is low, we can operate each instruction in register mode. And if it is high, we can operate each instruction in immediate mode. So basically, we can give a 1-bit instruction in the entire 32-bit instruction to whether to use a register or integer, rather than specifying memory for registers and integers side by side. And secondly, for branching, we have used finite state machine logic in program counter so that the branching is implemented through the conditional flagging. So the conditional flagging, we have used all the basics like jump not 0 and jump if yes and jump if no. So this is the first optimization technique, and the second one was implementation of pipelining. So we have gone to the depth of 4 stages: instruction fetch, instruction decode, instruction execute, and then write back. And then as a mean of testing, we have came up with a program of mean calculation, because at the heart of statistical algorithms, mean is the basic building block. So what we did was we did it first we implemented this test program in 2 parts. The first was addition, and then the second one was division. So in addition, we did it iteratively, trying to minimize the use of registers. And we also wanted to test the register integer class. So that's why we went with the approach of iterative addition. And then we tested the first 63 positive integers addition. And then we divided it with the number of all the integers. So these are the implementation details. We have used Xilinx Vivado for design purposes and test purposes. And then we used Verilog HDL to write our designed processor into it. And then the machine code that is being fed to the designed processor is taking binary inputs. And furthermore, we have choose the FPGA technology for hardware testing, and the FPGA board that we used was Digilent Nexus DDR4 because it is readily available in the market. And then we use the timescale of 1 nanosecond per 1 picosecond. These are our simulation results. As you can see, this is the basic 32-bit MIPS-based single cycle process. So it is without any optimization, and you can see that it is taking close to 6,000 microseconds to complete the entire program. And then this is the optimized version, and you can see that it is taking a little over 3,000 nanoseconds. These are the binary instructions that are being loaded into the program memory of the CPU. And then this is the pipeline in the top part. These are the pipeline stages, and at the bottom you can see the finite state machine and the program counter, which is 12340 12340. So we have a typo here for the results and observations, but I can explain it in a way. So as you can see that this is 3,385 nanoseconds for the optimized version, and for here it is 5,095 nanoseconds. So the factor that we are achieving is 1.77% faster, and we are using so this is 3,000, and the other one was close to 6,000. So we are achieving a factor of 1.77%. And then also we are decreasing the number of registers being used. In the non-optimized version, we have 68 registers being used, and in the optimized version, we have only 3 registers being used. And this is from my side, and please, you can ask any questions if you have.
Thank you so much, sir, for your presentation. Sir, do you have any questions?
Can you get back to where you have the register mode and the immediate mode? Okay. So you are saying that the operation can run on both register mode and immediate mode, or you are saying the experiment is based on the immediate mode? Can you hear me?
I can hear
Sharon?
you. I can hear you.
Okay.
My microphone was mute. So yes, we can use both of them.
Okay.
And we have tested both of them in the same program in the test algorithm because it is iterative. So it is first taking the immediate modes, and in the immediate mode, it is taking the variable and then calculating the results and storing it back, and then taking it and then storing it, adding and storing. If that answers
But
your
in this
question.
experiment, yeah, I know you did, but I thought I heard you say you preferred you are using the immediate mode because you want to avoid use of registers, and
No,
then you are
actually,
using.
maybe I did not presented it in a way. So what I meant is we can club it together in one instruction, and each instruction gives the value whether we are going to use register or immediate, rather than we are loading the memories from the memory into the registers and then executing our operations. So in each instruction, bit number 26 dictates whether we are going to use register as a second operation, a second operand, or we are going to use the immediate mode.
So when it is high, you use the immediate mode.
Yes, sir.
So what's the reason for that?
Sorry, what?
What's the reason for that? When it is high, you go on the immediate mode. When it is low, you go on the register mode.
So this is proposed into the SOMA instruction set architecture. This is a MISC, minimalist instruction set architecture, and this was proposed into the SOMA paper 2 years ago by Dr. Patrick and Dr. Andrew Scott. So I implemented that into the CPU basic 32-bit MIPS-based processor and see the output, how it is behaving. And then I check the feasibility onto the hardware.
Yeah, I'm interested because I teach architecture, and I will check some instruction set and to see what really it's happening there.
Yes, so
But
it is.
I'm sure. Is it a pilot study? You are just doing a pilot kind of thing, or?
Yes, actually, it was a theoretical concept, customized instruction set architecture, and with this paper, we have proved its feasibility and also the results onto the hardware technology using the FPGA. And then as a extension to this research project, we are currently planning on to bring it to a fabricated micro device.
Yeah, all MIPS instructions, they go on embedded systems. We know MIPS processors go on embedded systems. So of course, you know, you have to do that. So,
Yeah.
but because, well, Professor, do you have any comments?
No, sir. No further questions. Thank you, sir.
Okay. All right. Thank you. I will check your SOMA architecture, your SOMA instruction set architecture, and see how it's going.
Yes, please. Thank you so much.
And then when I will also advise that you can compare with some other MIPS platforms, or
We
you
have
take any other risk-based processor and check the performance with your that uses a different ISA, like there is RISC-V processor, and then you can compare. RISC-V is already in use, it's already been popularized, you know, and then you try to check what you are doing with any other risk-based architecture, and let's see what is happening.
Perfect, sir. I will make sure it goes this way.
Okay.
Thank you.
Thank you.
So much for your presentation. So you may please stop presenting now. On this note, I would sincerely like to thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough for you. We, on the behalf of the whole team, thank you for supporting this 8th version and all the 7 previous versions of the conference held in the Asia. We will be happy to have you in the 9th version in 2025 as well. All the presenters would be getting the digital certificates through email within 2 working days. Further, all the papers have been already forwarded to the printer. The publication will be live within 6 months. Kindly cooperate with the team of ICTIS 2024. On this note, I would also like to thank our session chair, Professor Iskil Yubis Oki, for chairing this session. So, this is a token of appreciation on the behalf of the whole team of ICTIS 2024 and the organizing partners. Do you have a closing remark for us?
Just to thank all the presenters. The papers are really good. All the presentations were good. The only thing I forgot is on the first presenter, she was working on a framework and we didn't see the framework. So if the framework is not there, she should try to include a framework based on the results of their study. But otherwise, all the presentations are good. The papers are very good, and I congratulate the presenters. Thank you.
Thank you, sir. Also, I would like to thank our next session chair,
Yes.
Professor Narendra Londe, for chairing this session. So this is a token of appreciation on the behalf of the whole team. So do you have any closing remarks for us?
Thank you, Anshika. I just want to say that the papers that were presented in this session were of variety. They were from the different fields, like from electrical and then also from the computer science. And so it was a really nice treat for me to stay here and to hear all of these presentations. I just wish all the best to all the participants for their future endeavors. Thank you so much. And it was really pleasure hearing Professor Oki. And this is the first time that I am seeing you, sir. Thank you so much for being here.
Okay, please do leave your email on the.
Sure, sir. Sure, sir. Sure. Sir.
Okay, okay,
I will.
so that we can interact. Okay.
I would like
Thank
to
you.
request
Thank you so much.
I would like to request
Okay.
everyone to please open their cameras for a quick snapshot.
Okay.
Can everyone please open their cameras?
Yeah, my camera is open.
Yes, sir. Thank you so much, everyone. Thank you for coming
Thank
to
you.
the session. Thank you.
Okay. Thank you. Bye.
Bye. Bye,
All
sir.
right.
Thank you.
Thank you.